Hi, good morning. Today we're going to talk about Math 101 and in particular section 1.3. All right, so we're going to call this our 1.3 online class. Remember the number here means that's the section in the text that we're going to cover in this online class. So let's note that the title of section 1.3 is fractions. So we're going to be doing a little bit of a review with fractions, how to simplify fractions, how to multiply fractions, how to divide fractions, and then how to add and subtract fractions. All right, let's plow through some examples in the text along with some selected problems from your homework list. This is example 1 in our textbook. It's on page 21 if you want to look along. It asks us to simplify the following fraction, 10/25. Well, of course, we know we can cancel out common fractions across a fraction bar. Let's see, the greatest common factor of 10 and 25 is 5. So I can claim 10 upstairs is 5 times 2, and 25 downstairs is 5 times 5, and I can cancel out the common 5s, hence left with a simplified answer of 2/5. Right, this is part A of example 1. Part B, similar. We are asked to simplify a fraction 6/18. Now what are we going to do here? The greatest common factor of 6 and 18 is 6. Well, what I can do is write the numerator as 6 times 1, and downstairs, of course, we know 18 is 6 times 3. I can cancel out the common factor of 6 across that fraction bar, and I'm left with a completely simplified answer of 1/3. All right, that's example 1B. Let's pick a homework problem. This is number 23 from the homework list. All right, exercise 23, again, simplify the following fraction, 10/15. Well, very similar to part A that we did above. 10 and 15, the greatest common factor is, of course, 5 again. 10 is 5 times 2. I'm having trouble drawing the 5s today, forgive me. So 10 is 5 times 2. Downstairs, 15 is 5 times 3. Canceling out the common 5s, I'm left with a final answer of 2/3. All right, so we've got a pretty good idea of what to do when we are asked to simplify fractions. Let's go up the ladder. Next thing I want to do is multiply fractions. And to multiply fractions, well, in general, if you've got a fraction with a over b and another one times c over d that you want to multiply, well, all you do is really multiply across. The numerator then the new numerator would be a times c, and the denominator would be b times d. Of course, we want to cross-cancel first and simplify our result if necessary. Let's look at example 2. In our text, this is on page 22. And this is, let's see, 3/13 again, multiply and simplify. 3/13 times 5/11. Notice there is no, hang on a minute. There is no common factors that I can cancel out here. 11 is not a multiple of 3. 13 is not a multiple of 5. There's nothing I can really cancel out or cross-cancel here before I multiply. Well, that's okay. So I'll just multiply across then. And upstairs, 3 times 5 is 15 for our new numerator. And downstairs, 13 times 11 is, well, I went to a calculator, it's 143. Now this cannot be simplified any further. And all these factors are what we call relatively prime. And when that happens, we've got a completely simplified answer. Sometimes it's hard to recognize, especially when numbers get larger in these fractions, whether they can be simplified or not. So beware of that. Example 3. In our text, let's see, part A, I've got 8/17 times 5/16. Multiply the two fractions and simplify as needed. Well, if I look to cross cancel, let me do this thing again here. 5 and 17, oh, what have I done? Hang a minute. 5 and 17 are what we call relatively prime. All right. Can't cross cancel anything here. But 8 and 16, yeah, we can do some surgery there. Right. So let me erase this and try again. 8 goes into 16 twice, does it not? So what I can say is 8 goes into 8 once. 8 goes into 16 twice. And now that I've cross-canceled as much as I can, now I will multiply across. 1 times 5 is 5 in my new numerator. Downstairs, 17 times 2 is 34. Final answer, 5/34. I can't get any simpler than that. Let's see, B, well, this one's a little nastier. 27 over 40 times 16 over 9. And again, I'm going to look to cross cancel. Let me do this drawing thing again. 27 and 9, I'm going to be able to cancel some things out there. And 16 and 40 also have some common factors. All right, so I'm going to look to do some surgery before I perform the actual multiplication. All right. Let's see, 9 cross cancels into 27 3 times, does it not? Think of it this way, 9 goes into 27 3 times, and 9 goes into 9 once. How about 16 and 40? Yeah, I think I can divide 8 into 16. 8 goes into 16 twice, and 8 goes into 45 times. All right, so it looks a lot better now. The magnitude of these numbers are all greatly reduced. Upstairs, 3 times 2 is 6. Downstairs, 5 times 1 is 5. 6/5 final answer. All right, that was example 3B in our text. Let's do one from the homework list. I want to do number 53. Number 53, so we've got 5/12 times 4/15. Now maybe a lot going on here. Again, I'm going to look to cross cancel. 5 and 15 contain some common factors. 5 goes into 5 once, and 5 goes into 15 3 times, does it not? Similarly, 4 and 12, well, 4 goes into 4 once, and 4 also goes into 12 3 times. All right, so cross-canceling as much as I can makes for an easier trip. 1 times 1 in the numerator is 1. Downstairs, 3 times 3 in the denominator is 9. Final answer, 1/9. All right, so that's 3 examples of multiplying fractions. Let's try to divide some fractions. Well, maybe you've heard the phrase keep, change, flip. In my day, we called it invert and multiply. If you're dividing fractions, well, if you invert the divisor fraction, you can turn it into a multiplication problem just like before. So I'll do that. I'll keep A over B. I'll change the division sign to a multiplication sign and flip or invert the divisor fraction and then simplify as needed. So keep, change, flip, invert, and multiply. All right, let's look at some examples. Example in the book, example 5 on page 23. Example 5a, we are asked to divide 3/5 divided by 5/6. All right, not a big deal, just a minor change will turn it into a multiplication problem, right? Keep, change, flip the divisor fraction into 6/5. All right, I'm looking to cancel some things out, and I don't see anything. 3 and 5, no, 3 doesn't go into 5, and 5 doesn't go into 6, vice versa. So I'll just multiply across now. 6 times 3. 6 times 3 upstairs is 18, and downstairs 25. So our final answer here is 18/25, right? All right, that's 5a. What about 5b? 3/5 divided by 12. Well, what are we going to do here? 3/5 divided by 12. 12 isn't a fraction. Well, I can write it as a fraction. I can write it as 12/1. Could I not? All right, and now we've got 12, the whole number 12, in the form of a fraction, and I'll do the same rule. Keep, change, flip. All right, now let's do some cross-canceling here. 3 goes into 3 once, and 3 goes into 12 4 times, and that's the only cross-canceling I can do. 1 times 1 is 1 in the numerator. Downstairs, 5 times 4 is 20. So final answer of 1/20, completely simplified. All right, let's try number 59 in the homework list. Oh, I need a new screen. All right. This is number 59 from our homework list. 3/4 divided by 1/2. All right, so divide the fractions and simplify. And again, keep, change, flip the divisor fraction. Now notice, 2 does go into 4 twice, so I'll make that cross cancellation. And 2 goes into 2 once, so I've got 3 times 1 in the numerator is going to be 3, and downstairs 2 times 1 is 2, or 3/2, final answer. All right. By the way, if your numerator is bigger than your denominator, we're not going to deal with mixed numbers here in this course, so let me write that down. No mixed numbers, please. I believe at this level and above of math, mixed numbers kind of lose their charm. It's easy to mix up a mixed number or confuse a mixed number for something that's not intended. Maybe we'll talk about that later. All right, so in any case, no mixed numbers. Leave it as an improper fraction if that's your answer. Where the numerator is bigger than the denominator. No mixed numbers, please. All right, talk about adding and subtracting fractions. The bane of all students everywhere. Well, to add and subtract fractions, you need what we call a common denominator. Denominator. We need a common denominator. All right. Well, let's jump right in and do some examples on the book. We've got example 6 on page 23. Example 6a says add 6 15ths plus 2 15ths. Well, we already have a common denominator in this situation. And when that happens, I just add or subtract the numerators as indicated. 6 plus 2 is 8, divided by, and retain the same common denominator, right? So 8 15ths will be our final answer here. That's an 8, believe it or not. Let me make that a little clearer. Eight over 15, okay? All right, that's what we do when the denominators are the same. Let's try subtraction. B, we'll say 8 13ths minus 5 13ths. Here it's a subtraction, but again, we need a common denominator, and it is a common denominator. 8 13ths minus 5 13ths. We'll just subtract the numerators as indicated and retain that common denominator. So I've got 3 13ths. Example 6b. Let's look at number 67 in our text. I've got 3 8ths plus 2 8ths. Add the fractions and simplify as needed. Well, the denominators are already common here, so I'll just add or subtract the numerators as needed. 3 plus 2 is 5, and just keep the same denominator. Retain that common denominator in your final answer. 5 8ths, final answer. All right, one more example in the book. Example 7 on page 24. We are asked to add 1/2 plus 1/5. Well, 1/2 plus 1/5, no, it's not 2/7. You need a common denominator here. You're going to have to do some surgery here. Let's see, I need the LCM, least common multiple, of 2 and 5 to get a common denominator. Well, what I want to do is express both these fractions equivalently with the LCM of 2 and 5 as my common denominator. Well, the LCM, the least common multiple of 2 and 5 is 10, is it not? So if I multiply numerator and denominator by 5, I'll get 5 over 10, right? 1/2 is 5/10 with 10 as a denominator. Similarly here, the second fraction, if I multiply both numerator and denominator by 2, I get 2/10. And now that my denominators are common, I'll just add my numerators as indicated and keep that common denominator in my final answer. All right. All right, I think we'll call it a day. I've done all the meaningful examples in the text, and this concludes section 1.3 or the 1.3 online class for Math 101.